that. Alright, so let's start off with number 1. Okay. And this is going to be a little bit of a hassle because the graph for it is on the back. So we'll have to get all the information, then kind of flip it back and forth to make it work. So 1 through 4, that's what the graphs on the back are, where it says graph the quadratic. Alright. Now, before you start graphing, you should probably know a few things. Does this open up or down? Opens up because this is positive 1, positive, so we know it's opening up. What is the y-intercept? Negative 3, so we know it's going to cross here, it's opening up. And remember, this number, the b, that's the slope at the y-intercept, so it's positive 2. So that means it's going like, kind of like up this, like up 2 over 1. That's the slope, so it probably looks something like this. Okay, roughly. Okay, and you want to kind of have that before you start. Now, this is what I think it's going to look like, so that way if it's dramatically different, if it's opening down and on the wrong side, you'll know it right away and say that's not right, something's wrong, you'll go back and check it. Otherwise, if you don't do this, any answer you get, you're like, well, I guess that's it, I don't know, and you have no way of judging if it's right or wrong. So keep that in mind. That's what our estimations tell us. Alright, and what we did is we went through and we did the vertex form. So you want to get this x minus h plus k, we want to put in this format. Okay, do the vertex form. To do that was complete the square. So we go through and we say complete the square. Okay, so what completes the square? So you take half of 2, square it, add 1. And since we added 1 on the right hand side, to keep it balanced we have to subtract 1. That way it stays, these will always equal 0. Has to stay the same. We can now write this as x plus 1 quantity squared minus 4, and your vertex is at negative 1 comma negative 4. So negative 1 comma negative 4. And we know that there's an symmetry here. So since I know the y-intercept is here, I have another point on this side, and we can kind of see where this graph is going. Okay. Now, depending on how detailed we want to get, we could go through and find the roots and solve this. So let's do that just for practice sake. So we have, to solve it, I just take this from here and I make it 0. Because remember, solving means finding x-intercepts. That's when the y is at 0. This is y is 1, 2, 3, 4. Y is negative, so we're trying to find x-intercepts. That's 0. So that's why we changed the y to 0. Alright. Add 4 to both sides. Square root both sides. That's how you get plus or minus 2 equals x plus 1. And then subtract 1. Negative 1 plus or minus 2 equals x. So negative 1 plus 2 is 1. Negative 1 minus 2, negative 3. So those are the x-intercepts. 1, negative 3. And that's probably as detailed as you'll need to get for your graphing purposes. Of course, the most important numbers are, do you know the y-intercepts right here, how we got those using this, and how to get this vertex. From vertex form, that's from completing the square. So it's kind of like 2 problems rolled into 1. And maybe for on your final, you may not have to go through and do the solving. You just really need the vertex. Think back to the beginning of the problem. Does our graph kind of look like how we thought it would look? Okay. So yeah, the vertex is on this side, my y-intercept is here, it's opening upward, all those things match up. So if it didn't, we would stop and say what's wrong. If you miss one little negative up here, maybe your graph is now down. One little negative will make a completely different graph. Alright, so that's number one all the way through. Let's see here. Let's go back here. Alright. Let's see here. Any requests 5 through 8? Number 8. Okay. Let's look at 8. So this says to write it in standard form. So that's like we want it to be y equals, like if we were going to try to do quadratic formula. And we need it to be looking like this. So step 1. Multiply those two together. Step 2. Multiply all that by -3. You don't have to go in that order, but it tends to work out better for most people. Alright, so I'm going to leave the -3 alone. I'm just going to multiply these two together, get a trinomial. So x times x. Remember, this is just foiling x times x times -6, 1 times x, 1 times -6. X squared minus 5x minus 6. And then lastly, distribute that -3 in. There's your standard form.
That's under 8.
Hmm? This is 8. Yeah, is this good? Plus 18. So remember, as you're doing this, try to do it along with me. Don't just look up, think, look down, copy, and you're not thinking or learning anything while we're doing this. If you do that for the next 4 days, you'll be no better prepared for the final than you are right now. If all you do is copy down what you see. So try to go ahead, try to think, well, you know, how you hear people. Wait a minute, that's not right. You should be doing this next. You should be trying to do this along with. All right, good. Okay. Do some solving. Anything in particular you want to look at? 9 through 12. 11? Okay. Alright, so I note that we have a squared, we have an x, and we have a number, so this is one step away from if I add 81 to both sides. That's a quadratic. So we can go through and factor this, see what we get. And what does it come out to? 9. So your answer is, yeah, x equals -9. Now, what does this look like, just for review's sake, if you graph this? What does this look like? What's that? It's a parabola, so opening up, opening down. Which one? Yeah, it opens up, that's positive. So we know it's opening up. The y-intercept is -9. I'm sorry, the x-intercept is -9. So what does that look like? If there's only one x-intercept, what does that look like? So parabola. Alright. So when you have one answer, that was the case when the answer is also the vertex. The vertex is at -9, 0. So we had that special case. What's the y-intercept? Okay, if we kept this going, where would it finally cross this? 81, the y-intercept. So I got way up there. So that's how to make a quick graph. So I just want to go over that special situation when the x-intercept is also the vertex. When you have only one answer, meaning both of these are identical, that's what that means. Good. Let's see here. Solve by finding the square roots. Alright. Any of these? By request? Skip them? Speak up.
Let's do 14.
Corton, there you go. Now, let's see here. Yeah, this is doable. Now, what you don't want to do is multiply this out, distribute the 3, subtract 81, and go through factoring. The fact that it's already in this form, it's like a vertex form. So it's easier instead to divide by the 3. Equals 81 divided by 3. 27. Okay. Square root both sides to deal with this square. X plus 1. Now sidebar. Square root of 27 is root 9 times root 3, which is 3 root 3. So I'm going to say this equals 3 root 3. Okay. And right now, what's missing? What did I leave off? Plus or minus. Very important. Alright, then go ahead and subtract 1 on both sides. And now we have x equals negative 1 plus or minus 3 root 3. There you go. So I guess the biggest thing here is just remember, reduce radicals when possible. Just like a fraction, no problem. If you came across a 3 over 6, you'd always change it to 1/2. You wouldn't even think about it. Same thing with radicals. You always just have to reduce it whenever it can be reduced. Alright, good. Not so bad. Alright, so complex numbers. I think the adding subtracting is pretty straightforward, right? We can do 8 plus 7, 15, negative 6 plus 4, and so on. Same thing, subtracting, just remember, distribute the negative. I think we're pretty good with 18 as well. Just multiply, just like we did earlier. 5 times 4, 5 times negative 2y. But the 19, there was something we had to do that was a little more work here. Alright. And I'm going to do a very similar problem right next to it at the same time, because the steps are identical. So the fact that this is an I, remember an I is just a square root of negative 1. So the rules for I, imaginary numbers, are the exact same rules for radicals, because imaginary number is a radical. That's why they're the same rules. So whenever you have an I in the denominator, it's the same thing as having a radical denominator, which we don't want. So the way we dealt with that is that we multiply by something called the conjugate. And that's when we change just the sign, connecting the two. So if it's positive here, we multiply by the opposite. So same thing here. Multiplied by negative 3 minus 6i, top and bottom. And with imaginaries, we figured out after a while that I squared equals negative 1. So anytime you multiply I times I, substitute it with negative 1. So we have 4i times negative 3, negative 12i. 4 times 6, negative 24. I times I, negative 1. So that's a plus 24, right? Negative 24 times negative 1, plus 24. On the bottom, 9. 6 times 6, 6 times negative 6, negative 36. And then the I times I, negative 1. So once again, negative 36, negative 1, plus 36. Generally, you see the real part written first, so we'd write 24 minus 12i all over, what is this, 45. Is there any number that goes into all three of these? 24, 12, and 45. 3. So I reduce it by a factor of 3. So 3 goes into all of them. Okay. 3 goes into here 15 times. 3 goes into here 8 times. 3 goes in here 4 times. So our final answer. There you have it. And really, I find after grading these, this is the most common part that's missed. Everybody will do all this other conjugate business and I times I and everything right, and at the very end they forget they have to distribute this. That's what's going on. That's why I have to divide this one and this one by 3. I can't just simplify just these two or these two. It has to be all 3 of them. Good. And if we went through, it's kind of a similar answer over here. Just instead of 4i, it would be 4 root 6. So exact same rules, just a different radical. Alright, so hopefully that's a good brush up on, again, this is called the conjugate. Alright, good. Let's see, complete the square. We already did that in number 1. Do we want to do another, really? I don't think we need to do another. What about here when there's a number in front? So remember, it's a little slightly different. This doesn't have a number in front of the x squared. This one does. Completing the square. I will point out, though, it says to solve by completing the square. Do you have to use that method? No, it's multiple choice. We're not going to know what method you use. You know, you'll get the same answer no matter what method. So if you want to try factoring, you could. But if you look at the answers and there's a bunch of radicals, you know factoring is not going to work. You could try quadratic formula. Okay, so just realize the method they tell you to use not necessarily required because we're not checking, you know, exactly what method you used. Okay, so let's see here. Let's do completing the square. Okay, well, that's the first step. Okay, a couple ways of doing this. Yeah, let's factor. Let's move this one out of the way. Let's do that. Okay. Equals -1 And let's go ahead and divide out 3. Divide everything by 3. Just one way of doing it. You might have another way. That's okay too. Let's complete this square. So what do we have to add to complete this square? So half of -4 is -2. -2 squared is 4. Add 4 to both sides. So we have x minus 2 quantity squared. 4 minus 1/3 be 3 2/3, which is what, 11/3. And square root both sides. Add 2 to both sides. So we have plus or minus 11/3 square root. Add 2 to both sides, so we'll have x equals 2 plus or minus square root of 11/3. And of course, did the quadratic formula, same exact answer. Alright, good. And yeah, let's see, quadratic formula, I don't know if we need to go over that. I will say on number 22. To use the quadratic formula, it has to be equal to what? 0. So here's the question. Should I subtract 9x squared on both sides? Or should I add 6x and add 1? Should I make the left 0 or the right hand side 0? Which side? Sorry, here are your choices. Let's copy that. Paste it. That's a good question. Doesn't matter. So one way we can do this, get negative 9x squared equals, no, not equals, minus 6x minus 1. Over here, if I want to make the right hand side 0, it'd be 9x squared plus 6x plus 1. This has all negatives, this has all positives. Alright, so let's see here. We'll have negative 6 plus or minus negative 6 squared minus 4 times negative 9 times negative 1 all over 2a 6 plus or minus, let's do that, 36. Is that plus 1 or plus 36 or minus 36? It's minus 36, right? So negative 4 times negative 9 times negative 1. Don't forget about this as a negative. Don't just multiply these two. It's all of them. Negative 4, negative 9, negative 1, negative 36. All over negative 18. Alright. What if we did it the other way? 6 plus or minus 6 squared minus 4 times a times c all over 2a. Oh, negative 6 right here. All over 2a. So we'll get negative 6 plus or minus square root of 36 minus 36 all over 18. So are these the same, or do these give us the same answer? What's different about these? All right. You can see that here the negative's here, on this one the negative's here. So 6 plus or minus 0 over negative 18 equals what? Negative 1/3. And I'll actually put the negative down here on the bottom. Over here I'll get negative 6 plus or minus 0 over 18. So I'll get an answer of negative 1/3. So are they the same? Yeah. So it doesn't matter which way you go? No. Now, just for negative sake, would you rather have the one that has all the negatives in it or without all negatives? So you could think of it as, yeah, you get the same answer either way, but logistically, I probably want to go the way that gives me fewer negatives just so I don't make mistakes. So yeah. Now, are these graphs the same? Think about that. Are these the same graph? No, they're not. So this only works if we're solving but not graphing. Because if we're graphing, this is clearly opening down. Okay? And actually this is the x-intercept, negative 1/3. This one's opening down. The vertex is at negative 1/3. And this one over here, right, that's positive. So that's opening up. So these parabolas are actually like mirror images of one another. One's opening up, one's opening down, but they do have the exact same x-intercept. All right. Good problem, has a lot of good review in there. And lastly, here's the last two graphs on the back side are for those two. So there's 1 through 4, and then 25, 26. That's 6 graphs total. These are the same as 1 through 4, but they're inequalities. So remember, solid, dotted, and shading, just like we did just now with inequalities, linear inequalities. Same thing here, solid, dotted with shading. So you shade below the parabola, above the parabola. The parabola could be dotted or it could be solid. All right, so that's about everything. All right, and then again we'll start on Tuesday. We'll start this. We will not get a whole lot done on Tuesday. This is a lot of stuff. So again, don't expect us to come here and do math for next week only in class and then expect to do well in the final. It will take some time of studying outside of class to do well in the final. It's a lot of stuff.